This lesson is on how to utilize some of the tools that are within the AZ Merit testing system to help you either verify or find your answers. So I'm going to do a few sample problems. So I'm going to start with problem 2. It says we have a line segment that has endpoints of -9, 4, and 6, 5. So I'm going to do a quick rough sketch of that. So -9, -4. So we're going to say that point's here, and 6, 5 would be somewhere in this neighborhood. So I'm going to connect these two. So this is point T, this is point S. So the problem says we have a point R that lies on ST such that the ratio of SR to RT is 2 to 1. So SR is going to be twice as big as RT. So if we were to break this into thirds, SR would be 2/3 of the length of the entire segment, and RT would be 1/3. So I'm going to go ahead and create, that's not a very good line, so let's see if I can do that a little better. So I'm going to go ahead and create a right triangle here. And here we can see you have similar triangles. So similar triangles are in proportion to one another. So we want to figure out this ordered pair here. So let's start by looking at the distance between S and T on our x coordinate. So -9 to 6 is going to be 15 units. So the entire way is 15 units. But to get to R, we're only going 2/3 of the way from this point. So 2/3 of 15 is equal to 10. So we just need to go from -9, we just need to go in 10 units. And then this value here from -4 to 5 is 9 units. 2/3 of 9 is going to be 6. So we're going to go over 10 up 6 to get to point R. But remember, we're starting at point S. So we have -9 plus 10 and -4 plus 6. So our new ordered pair is going to be 1, 2. But let's go ahead and check this answer. AZ Merit has a pretty cool calculator tool that you can use. So we're going to pull out the calculator and let's plot all of the ordered pairs that they gave us. So -9, -4, 6, 5, and then our ordered pair that we found, 1, 2. So let's look at that and see if it looks like it's 2/3 of the way. So yeah, that looks like it's twice as big as this distance. It lies on this line, which is what we wanted. So that gives us some confirmation there that we did the problem correctly. All right, so let's go ahead and look at another example. Let's look at this one. So this one it gives us a quadrilateral, and it gives us all the vertices for that quadrilateral, and it wants us to analyze which statement is true. So I would start by plotting all of those points on your calculator or on the Desmos app within AZ Merit to get an idea as to what that looks like. So let me just get to that question. So here we are. So we're going to pull up the calculator. We're going to plot all of those ordered pairs. So we have 1, 3. We have 4, 1. Notice again, I separate my ordered pairs by a comma. 1, -3. And -2, -1. Okay. Make sure I have those in correctly. 1, -3, 4, 1, 1, 3. All right. So let's look and see what we notice about this. So just at a quick glance, it looks like it could be a parallelogram. Not sure. So let's read the statement. So since the diagonals of a quadrilateral are not congruent, it is not a rectangle. Okay. Since the adjacent sides have equal slopes, so the sides next to each other have equal slopes, it is not a rectangle. So adjacent sides means next to, those clearly do not have equal slopes, so we can throw that answer out. Since the diagonals are congruent, it is a rectangle. There's more than just that to prove that something's a rectangle, but let's look. 1, 2, 3, 4, 5, 6 is the length of that diagonal. And then we would need to use the distance formula to find the length of that, or we could use the Pythagorean theorem. So 1, 2, 3, 4, 5, 6. So 6 squared plus 2 squared, so 36 plus 4 is 40. So the square root of 40 is not 6, so we know that one's not true. And then it says that the slopes of the adjacent sides are negative reciprocals of one another. So let's see if that's true. So the slope of this, 1, 2, 3, 4. So that slope is 4/3. Let's see what this slope is. This slope is negative 2/3. Those are not negative reciprocals of one another, so that is not true either. So that leaves A. It says since the diagonals are not congruent, it's not a rectangle. Well, that's true. And in general, that's always a true statement. We just needed to make certain that it was true for this figure. Okay. So on this question, what I just wanted to talk about briefly was how to eliminate two answers right off the bat. So this is the image that we started with. So this is our pre-image, and after 2 translations, we ended up with this image. Clearly, we went from a smaller triangle to a bigger triangle. So that means your dilation is going to be greater than 1. So right away, you can get rid of answers C and D. And then from that point, you just need to determine, okay, so A, B, which one of these are true? So and the only difference between these two answers is that you either had 180 degrees clockwise rotation or a reflection over the line y equals x. So there are 2 strategies you could use for this. You could use our grapher and plot each of the 2 triangles and graph the line y equals x, because you do have an unlimited amount of time, so that's a way to be certain. Because remember, reflection over the line y equals x, this is our y equals x line. Okay, a rotation about the origin, that would mean that you would take each point and rotate them 180 degrees about the origin. So just briefly looking at this and just comparing these two coordinates here, let's go ahead and just do a dilation of a scale factor of 2. So it's going to go about here. So your new f coordinate is going to be somewhere around here. That clearly is a reflection over the line y equals x. But again, just to be on the safe side, it's okay to go ahead and plug it into your Desmos grapher and see what that looks like.